Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at kites, parallelograms and trapeziums, specifically look at calculating their areas. So here we have a kite. A kite is a quadrilateral, a four-sided shape that has two pairs of adjacent equal sides. What that means is in a kite, it's the two pairs of sides next to each other that are equal. Whereas for a parallelogram, it's actually the opposite sides. Pairs of opposite sides are equal. So make sure you know the difference because you can't find the area of a shape if you don't know what the shape is. So the area of a kite is xy over 2, where x and y are the two diagonals. The area of a parallelogram, a quadrilateral with two pairs of parallel sides, is b times h. Remember, h in measurement always means perpendicular height. So it's base, but it's perpendicular height, not slant height. On the other hand, a trapezium is a four-sided shape with just one pair of parallel lines. And here, the area of a trapezium is perpendicular height divided by 2, and then you multiply that by the sum of the two parallel sides. So let's look at some quick examples. So here we have a kite. Now I want you also to note that a rhombus is a special type of kite, so the area of a rhombus is calculated the same way as it is for a kite. So for this shape here, the area is just going to be the two diagonals multiplied together, and then you divide by 2. So 8 times 10 divided by 2 is 40. No units were given, we'll just write units squared. For this parallelogram here, I know it's a parallelogram because it has two pairs of parallel sides. The area is base times perpendicular height. So the base is 10, perpendicular height is 6. This slant height allows us to calculate perimeter, but doesn't help us calculate the area. The area of this parallelogram is just going to be 6 times 10, which is 60. Once again, no units given, we just write units squared. So here we have an example of a trapezium. I know it's a trapezium because there's only one pair of parallel lines. So the area of a trapezium, we take the perpendicular height divided by 2, and then we multiply by the sum of the two parallel sides. So it's 6 times by 40, which gives us 240, and again, I'll write units squared. All right, let's now look at some harder problem. So let's say the area of a trapezium is 336, height is 16, one parallel side 16 more than the other. Calculate the length of each of the parallel sides. So whether it's a parallelogram, kite, trapezium, or any other shape, if we are wanting to find dimensions, if we want to find side lengths, we set up an equation. So we know that the area is 336. So let's start by writing the area formula for a trapezium. This is a quadrilateral with just one pair of parallel sides. So now we're just going to substitute in everything that we know. We're told A is 336. We're told the perpendicular height is equal to 16. Now for A and B, we have two unknowns here. We can't really solve this equation with two unknowns because there would be infinitely many solutions. However, we're told one in terms of the other. We're told one parallel side is 16 more than the other. So if one parallel side's A, I can write the other parallel side as A plus 16. So here we have one parallel side and the second. See, the goal of interpreting this information was to come up with an equation that has only one pronumeral because we know how to solve those equations. So here we have 336, 16 over 2 is 8. So A plus 16, we can just write that as 2A plus 16. And I know you know how to solve this one, so first thing we can do is divide each side by 8. Then we subtract 16 from both sides, and then we divide by 2. We get A equals 13. So what that means is the parallel sides are going to be one is 13 and the other is 13 plus 16, which is 29. Of course, both will be in centimeters. So why is that? 16 over 2 multiplied by 13 plus 29. 16 over 2 times 42 gives 336. So follow a similar process whenever you're finding a side length. Write the formula, substitute in everything you know, and then rearrange to find the unknown side. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.